Dear students, in the previous class, we have discussed solids in liquid solutions and the factors affecting them. And now we are discussing gases in liquid solution and the factors affecting the solubility. So the first factor which affect the solubility of gas in liquid is nature of gas. Gases which react more effectively with the solvent are more soluble, and the gases which are easily liquefiable. Now the liquefaction of a gas depends upon the critical temperature, which is denoted by Tc. What is critical temperature? The temperature above which a gas cannot be liquefied. So higher the critical temperature, more easily it is going to be liquefied, like SO2 gas, CO2 gas, or NH3. Now the second factor is effect of temperature. When the gas is dissolved in liquid, this process is exothermic. So we have already studied that in exothermic processes, solubility decreases with increase in temperature. Now the next factor which affects the solubility of a gas is pressure, and it is very important point. So the solubility of gases increases with increase in pressure. This was actually explained by a scientist named Henry, and he gave a law, that is the Henry's law. According to this law, the mass of dissolved gas per unit volume of the solvent at a constant temperature is directly proportional to the pressure of the gas in equilibrium with the solution. So M, that is the mass of dissolved gas, is directly proportional to the pressure of the gas in equilibrium. If we remove the proportionality sign, then constant of proportionality K will be here, M equals to Kp. At the same time, Dalton was also studying the effect of pressure on the gas. So he gave a relation, that is X is directly proportional to P. Here X is the mole fraction of the gas dissolved, is directly proportional to the P pressure applied on the gas. So X is equals to K dash P. K dash is again the proportionality constant. So if I write 1 by K dash into X is equals to P, then here 1 by K dash is equals to KH, which is Henry's constant. KH is the Henry's constant. So the relation is KH into X is equals to P. Now if we discuss the characteristics of Henry's constant, then the first point is all the gases have a different value of KH, that is Henry's constant. Second characteristic, value of KH at the same temperature is constant. However, it increases with increase in temperature. And the third characteristic of KH is very important, that is KH is inversely proportional to solubility. Now if we talk about the example, then like CO2 gas, it has the KH value 1.67 kilobar, helium has 144.97 kilobar, oxygen at 293 34.86, and oxygen at 303 Kelvin 46.82. So if we see the value of KH in case of oxygen at 293 and at a higher temperature, we are seeing that the value of KH is increasing. The value of KH is increasing, that means the solubility is going to decrease. So from this point, a 1 mark question may come into exam, that why aquatic animals are not comfortable in warm water. So the answer is, as the KH value increases, because we are seeing the value at 293 Kelvin, oxygen at 293 and oxygen at 303 Kelvin, the value of KH is increasing with temperature, but we know that KH is inversely proportional to solubility, so the solubility will decrease in warm water. Therefore, aquatic animals are not comfortable in warm water.